Think forward. Think Research Channel.
The following is a presentation of the American Meteorological Society. Founded in 1919, the 13,000-plus members of the American Meteorological Society strive to advance and communicate knowledge concerning the atmosphere and related sciences, technologies, applications, and services for the benefit of society.
Well, good afternoon, and thank you very much for coming here. I'm going to jump right into this and give my perspectives on the operational hurricane forecasting, and then talk about some things we can hopefully change in the future. Just to kind of give you the perspective again, a very brief overview here. The 2005 hurricane season set all kinds of records, 28 named storms. 15 of those were hurricanes. We had 7 major hurricanes. We had 4 major hurricanes hit the United States. Wilma had the lowest central pressure ever recorded in the Atlantic Basin. The accumulated cyclone energy index was the highest we've ever had, and it was the costliest season on record, with Katrina being the single costliest hurricane as well. I think most of us remember the track of Katrina in the Gulf of Mexico, but let's not forget there in the beginning, it moved initially towards the northwest, then the north and west, made landfall and took a dive down to the southwest, and posed some challenges for us there at the Hurricane Center, and then it took that gradual turn up into the north central Gulf Coast. These are daily pictures through the life of Katrina. It became a tropical depression on the 23rd of August, on Tuesday there. A storm in the southeastern Bahamas. On the 24th, a storm over the central Bahamas. The 24th, it made landfall in southeastern Florida. The 26th, Category 2 hurricane in the southeastern Gulf of Mexico. The 27th, 2 days before landfall, a Category 3. 1 day before landfall, a Cat 5. And then it weakened down, believe it or not, to a Category 3 hurricane at landfall on the Monday morning, the 29th of August here. Now here's the satellite loop, and you can see it developing there over the Bahamas and along its path there. There are some people in South Florida who complain that they didn't have enough warning. We're talking about the first landfall in the United States there in southeast Florida, and what they really meant was that Katrina did not develop until it got over the Bahamas, only 2 days before it made that initial landfall. There's no law, there's certainly no physical law that says they have to all form the Eastern Atlantic, and the forecasters will certainly tell you that they need more help on genesis. We've got a long way to go before the models can accurately predict genesis there. The radar loop from Miami shows the landfall there on the Miami-Dade Broward County line, and then it took that dive down to the southwest. That was not very well forecast by the models, although one model, the GFDL model, did show a southwestward motion, although it showed that over the Bahamas, and if you believe the initial tracks there, it wouldn't have even hit Florida. So that was a little bit surprise for us, but we did have the warning up in those areas. The ocean heat content, our oceanographer friends have told us not just to look at sea surface temperature. We need to look at the ocean heat content, and part of the circulation of Katrina moved over the warm loop current and a warm eddy there, and that certainly helped the intensification. That's not all there is to intensification, but we do need more guidance on how to make use of some of these products like this. Now here's the Slidell radar, and I'll show this to let you know, as bad as things were here in New Orleans and southeast Louisiana, it could have been even worse. And hopefully you can see Lake Pontchartrain right here. There's New Orleans. Here comes the eye over the extreme southeastern part of Louisiana, the mouth Mississippi River, and then up into near the Mississippi Louisiana border. The strongest winds were definitely on the east side into Mississippi, and in fact, I think back to Sunday, I took the bus tour of New Orleans, and our tour guide did a marvelous job, but she did say one thing that I still remember. She said the winds were 200 to 250 miles per hour in New Orleans. Well, that didn't happen. In fact, New Orleans proper likely experienced only Category 1 or Category 2 conditions. It could have been worse. Now this is, in the amount of time I've got here, this shows the red area shows the swath of hurricane-force winds. The orange shows the area depicted by the tropical storm-force winds based on the initial advisories at 6 hourly time intervals there. And you can see here in the Gulf of Mexico, the size really did increase. In fact, on the 27th, the radius of tropical storm-force winds and hurricane-force winds about doubled and then continued to increase. And with the hurricane-force winds going out about 90 miles from the center, the tropical storm-force winds going out over 200 miles from the center of the hurricane, we do a much better job of observing that. But we don't do is, I think all the hurricane forecasters would agree that we need more help on forecasting those changes in the size. Here's the storm surge animation, and you can see the Mississippi River down here. There's Lake Pontchartrain. There's New Orleans itself. Here comes the hurricane. And you can see how the water piles up there as the winds go counterclockwise around the center. Now, this was done after the fact based on the best track of the hurricane. And if you look at this little area right here that labeled New Orleans, that looks like it was high and dry. We're going to talk about that a little bit here. There's so much focus on New Orleans, but I can assure you that even if New Orleans itself had not flooded because of the breaks in the flood walls primarily, this would still have been a catastrophe. You look down here at Plaquemines Parish and St. Bernard Parish on the Mississippi Gulf Coast. In fact, the storm surge values are 24 to 28 feet around Bay St. Louis, up where you see the red in this area here, and even 16, 17, 18 feet in the area here around St. Bernard and around the mouth of the Mississippi River here. Now, we've gotten quite a few accolades from a lot of people on the good forecast on Katrina, but I don't really want people thinking that we're going to give that perfect a forecast every time. And we don't want people making evacuation decisions based on an individual storm surge run. What the decision makers should have been looking at is something called the maximum envelope of water, from the storm surge model. This is a composite of several different hurricanes. This example shows Category 4 hurricanes moving northward at 15 miles per hour, and you can see the area that, what could have happened. It could very easily have been one of these easternmost tracks or one of the westernmost tracks, and it's extremely important to understand that to get a perfect storm surge forecast, you have to have a perfect forecast of the track, a perfect forecast of the intensity, and a perfect forecast of the structure, including the radius of maximum wind. I don't know how to forecast those changes in structure, and we don't have anyone at the National Hurricane Center who knows how to forecast that. Now, this is a graphic from the Times-Picayune newspaper. And here's the mouth of this is the Mississippi River. Lake Pontchartrain's up here. The folks who were on the bus tour the other day, this is the Lower Ninth Ward, New Orleans East. And here we are, this is the Industrial Canal. The little star there shows some of the breaks in the Industrial Canal. The London Avenue Canal is right here. And then the 17th Street Canal is way over here. The reds and the blacks are the deepest water, but about 80% of New Orleans flooded. This area in here primarily due to those breaks, and these three, the flood walls in this area. But without the major breaks like that, all this area was just tremendously flooded. There's a little, here's this line up here is Interstate 510. There's a power plant here on the north side of the Intracoastal Waterway. Some folks stayed there during the hurricane, and this is one of the pictures they took. You can see the storm surge and the wave action on top of the surge. And somewhere under here, there's a levee that was actually not breached. This is actually overtopped in this area. tremendous amount of attention on New Orleans, as it should have been, but we don't want to forget about the other areas. On the Mississippi coast, some before and after pictures. A cubic yard of water weighs about 1,700 pounds. It can come in along with that very dangerous wave action on top of it, almost like a bulldozer, and this is what can happen here. This is also on the Mississippi coast. A lot of people have asked us to draw a line in the sand and say that the wind did this and the water did that. And I like to use an example of having a bowl of soup on your dinner table. If you blow in that bowl of soup, some of that soup's going to splash out. So you can ask the question, what stained your white tablecloth? The soup or the fact that you blew on it? Well, they go together. And the storm surge is there because of the wind. And I think it is a shame that a homeowner in our country can't purchase insurance for all the hazards. And it's just too bad, in my opinion, that you get bounced back and forth between your insurance company for your homeowner's policy and the National Flood Insurance Program. There are countless stories. I'm just going to share one here because the gentleman who used to own this bed and breakfast in Bay St. Louis by the name of Doug Nollet happened to be one of the pilots, or used to be a pilot with the hurricane hunters in the Air Force. He was here in this house with the two new owners, and the storm surge came in. You can kind of focus on this fork in the tree right here. That's a before and that's an after picture. And they ended up, the three of them, back on one of these branches on this big oak tree in the back of the yard. Of course, they were lucky. They made it. A lot of people went through something similar and did not. This is a graphic from the Hydrometeorological Prediction Center showing the rainfall. We had about 16.5 inches in South Florida, around 15 inches here in southeast Louisiana, spreading all the way up into New England. From the Storm Prediction Center, depiction of the tornadoes well away from the center. And I just put those in to say that, you know, the National Hurricane Center is getting input from the rainfall experts and the tornado experts in these other national centers, and also to remind me to say that we know that a hurricane is not just a coastal event. The strong winds, heavy rains, and those tornadoes can spread well inland. Now, I always like to show audiences exactly what we were looking at down at the National Hurricane Center when we made some of these forecasts. This is from the 24th of August, 5 days before landfall, when it was just a tropical storm over the central Bahamas. This is the actual track that you see here in white on the left. These are some of the better performing operational models that we received at the Hurricane Center, and this is exactly what we saw from these models this time. The global forecast system had Katrina going over South Florida to Tampa, and then up here, these, again, 5-day forecast has it near the Georgia-South Carolina border. The GFDL model, one of our better performing models, has it making landfall in the Florida Panhandle east of Apalachicola. The no gaps is over here. The official forecast, the forecasters did a really good job here. At least they were leaning on the left side of that model guidance. And then by Friday evening, actually even by Friday afternoon, the models had shifted westward towards Mississippi and Louisiana. The models came into much better agreement and thankfully remained in good agreement, and we did indeed have a very good forecast. One thing that we're doing right there at the National Hurricane Center, before every advisory goes out, we have a hurricane hotline call with the local forecast offices in the path of the hurricane. We also have the Department of Defense meteorologist online, Navy Norfolk, for example. The NASA's on this line, so the federal meteorological community is very well coordinated. If anybody thinks we're overlooking something or they don't understand the forecast, the hurricane forecaster can tell them why they're doing what they are. Another success story, the Hurricane Liaison Team. This is a partnership with FEMA, where we briefed not only FEMA, but the emergency operations centers in the state. So in the example of Katrina, we actually had Texas all the way through Florida and Georgia online. Occasionally some of the governors participate in that, but at least the emergency management officials are in on that. The last briefing we gave before landfall on Sunday at noon, I gave the briefing, and my goal is to do the meteorology in 5 or 10 minutes and then get out of the way and let the emergency managers do their emergency management talk. But here I am down here on the bottom. After I talked, the former FEMA director, Mike Brown, said, "Thank you. Now, ladies and gentlemen, I'd like to take you to Crawford, Texas." And so I didn't even know the president was online, to tell you the truth. And the media's kind of made a big deal out of that, and I don't think they should have, because it's not like we had a secret forecast. I mean, I'm briefing off the most recent forecast, the same thing that you all could get on the internet and my wife and kids were looking at too. So how were the forecasts? Well, this is the success story here. With the track forecasting, the errors have been cut in half over the last 15 years or so, and you can see the 24-hour forecast in red, the 48-hour forecast in green, the 3-day forecast in orange here. Two things I like to share about this graphic. One is that we're improving faster at the longer time periods, and that's allowed us to go to the 4- and 5-day forecast a few years ago. And two, if you just look at 24 hours, if you just look at that red line, and let's just go back 5 years, the average forecast error in 24 hours on the track is 55 nautical miles. That's the average. And that's something we all need to take into account. What that means is we could be forecasting a hurricane to hit New Orleans that could very easily be 55 miles up or down the coastline. Now, that's a graphic that is usually shown to Congress, but the forecasters, and we all know there's a lot more to it than that. The Hurricane Center is making a 5-day forecast every 6 hours. This shows the average track forecast, and I just chose the 72-hour time period here. For the 2005 average at the 3-day period, the Katrina average was a little bit worse than that. But if you look at the individual forecast, and here we are about 3 days before landfall, these were really good forecasts. But if you go back another day before that, these were not so good. And we've seen a couple of examples of that. So, you know, it's a lot more than just the averages that are important. We've still got a lot of work to do here. The guidance, the models here, I just show this to kind of show that different models seem to perform the best for a year or two, and then that changes. The modeling centers are continually upgrading these models, and it's a little bit like the stock market. Past performance is no guarantee of future results. And the forecasters have done a superb job in being able to take these models, and they're really making very good use of the consensus models at this time. Now, there are some cartoons out there that have implied we didn't have a perfect forecast because we have had a budget crisis, and we could all do more with more resources, but there are some success stories, and this is one of them. I'm very thankful to Congress for appropriating money to allow NOAA to buy a Gulfstream 4 jet aircraft that doesn't fly into the hurricane, but in the environment around the hurricane, releases these drop zones that will sample the steering currents, and then that information gets in the computer models. Here's a poster child for that jet, who, well, in my opinion, that jet has more than paid for itself. The red line here shows the global forecast system of the National Weather Service without the jet data. The green line shows it with the data, and then the black line is the actual track. So the track was very, very good with the data, and we've got several examples to show like this. Now, intensity, a long way to go. On this, if you look at this graphic, it's pretty much flatlined. You could say on average we do a pretty good job. At 24 hours we're off about 10 knots. At 2 days' time we're off about 15 knots. And about 20 knots at 3 days' time. That's not too bad on average, but what we don't do a good job at is catching those rapidly intensifying or rapidly weakening hurricanes. And in the previous session I said that one of these days we're going to get people going to bed at night preparing for a Category 1 hurricane and waking up to a Katrina or an Andrew, and that will be another catastrophe. The National Hurricane Center has listed this as the #1 area where they need help from the research community. Now, we do have some successes there. We're the only country I know of that can afford routine aircraft reconnaissance from both NOAA and the Air Force. We've also, we need to thank Congress for putting this little pod and instrument on the aircraft now. It's called the Step Frequency Microwave Radiometer. This coming season, all the Air Force planes, as well as the NOAA planes, will have this instrument. NOAA's been developing this with the private sector for longer than I'd like for you to know, but at least it is operational now, which will allow us to have surface winds, not just the flight level winds, but surface winds everywhere that airplane flies. So observation-wise, we're doing much, much better, but we still need help in forecasting the intensity. I just want to show the drop wind zones. That the step frequency is great for surface winds, but we really want to see what's going on throughout the depth of the circulation there. These drop zones are still providing very, very useful information, and we'll keep getting those for a number of years here. The NOAA P-3 aircraft have a Doppler radar on board, and the top picture here was taken in the afternoon before landfall, and you can see the red area here where the really strong winds are in the eye wall itself, extending down toward the surface. Then down below there is at the time of landfall, and you don't see those strong winds extending down to the surface. This Doppler data indicated that we had this very broad wind max in fact, up near flight level, around 700 millibars. And this was extremely useful information to us when we downgraded Katrina to a Category 3 after the fact. Perhaps this is the next major investment we can make in the hurricane program, to put these Doppler radars on the Air Force planes as well. I don't have time to talk about all the wonderful satellite products that we're getting now. Just mention this one, the trim information from one of the NASA satellites. On the picture on the left, you can see the little pinhole eye with a very small diameter eye wall. Then later, an outer eye wall formed, and the innermost eye wall dissipated, and then that other one strengthened, and that went through another series there. We do a much better job now of observing these changes in the inner core, but I don't know how to forecast those changes. And every forecaster will tell you they would love to have some guidance on this. So it's one thing to say, something has happened, we've had an eye wall replacement cycle, but if you know how to forecast that, I think there's some people at the Hurricane Center that would love to talk to you. Very briefly, the intensity aids that we look at. The top line here shows the actual intensity of Katrina. The models down here did not even hint that we'd have a Category 5 hurricane. The GFDL did forecast it to a Category 1. This is back on the 24th. The ship's model actually kept it as a tropical storm. The Navy version of the GFDL actually dissipated it. So we obviously need a lot of help with intensity. I'll just show one example. This is from this last year. The black line here represents the official forecast. In this graphic, the higher the line, the better the forecast. And you can see the official forecast beat all the guidance. The statistical models are next, and then the dynamical models are still lagging way behind. A long way to go there. Now, this is what I really want to talk to you about. We've talked about the forecasting, but how do we do things better to change the outcome in future hurricane events? And one thing, and this is, in my opinion, a real success story of the United States Weather Research Program. They've got this Joint Hurricane Test Bed established at the National Hurricane Center. They've gone through about 50 projects now, and I'm only going to take the time to share one of these with you. The Hurricane Center has, for several years here, with every forecast, they've also issued this cone of uncertainty. And the official track usually stays within that cone about 2/3 of the time. And this was an example when the Hurricane Watch was first issued. But that graphic really only tells you a very limited amount of information. It tells you where the center of the storm or hurricane might be up to 5 days. The new graphics, this is an example of the probability of hurricane force winds from that same time period, starting at 5%. If you look at the yellow area there, that's a 30% probability of hurricane force winds, and it's certainly focused on southeastern Louisiana. If you look at the probability of tropical storm force winds, you'll see it goes from southwest Louisiana all the way over into the Florida Panhandle. And this graphic accounts for the uncertainty in the track, the uncertainty in the intensity, and the variability in the size of the hurricane. And I really think this helps deal with there's certainly some difficulty in watches and warnings, and I've even heard it mentioned here at the conference that some people think a warning automatically means evacuation. That's not the case. If you live in a well-built house outside the storm surge zone, we don't want you to evacuate and add to a potential gridlock. But a lot of education is needed. This is an ongoing process for the public and for the emergency managers. We've absolutely got to do a better job of this. And one way to do it is through something like the National Hurricane Preparedness Week. A lot of good stuff on the website here on the basics on hurricanes, on the forecasting, the hazards. And the last day of Hurricane Preparedness Week is the National Day of Family Preparedness. It's a perfect time for people to dust off their hurricane. I don't give any talks these days. Actually, I haven't even when I was the director of the Hurricane Center without mentioning the importance of building codes. I'll share this example of a tale of two houses. The owner of this home went to a neighbor's house to ride out a hurricane. This was actually Hurricane Charlie. Saw the windows blow in, the roof blew off of his house. And this is the house right across the street built to the new Florida building code. Better building will not only help save lives, but it will help tremendously in cutting down on the insurance payouts. Makes good sense to me here. Now, there are so many disciplines that are involved in the nation's hurricane warning program, way beyond the forecasting, and I want to give credit here. The first time I heard this idea came from Dr. Bill Hook, and I really think he's onto something. He uses the example of the National Transportation Safety Board. If there's an airplane crash, they don't wait for some congressional committee to be formed. They send out a team immediately to find out what happened. If they find out that there's something wrong with that airplane, mechanically, that plane would never be built like that again. And we don't really do that for disasters. We had Senate reports, House reports, White House reports after Katrina, mostly focused on response, and certainly there should have been focused on there, but maybe we need something along the lines of a National Disaster Review Board. We don't really care what you call it, but to bring all these disciplines together, the meteorologists, the emergency managers, the media, the behavioral scientists, the land use people, the building code people, the insurance folks, and get them talking to each other and empower that board to at least give some direction and guidance to the different disciplines there. And with that, I will end with this one last slide. I think most reasonable people can look at this one graphic here that shows all the hurricanes in the Atlantic Basin and the Pacific since 1851, and understand that the United States of America indeed has a hurricane problem. Thank you very much for your attention.
Think Forward. Think Research Channel.